Welcome back. So, friends, we are discussing about, welcome back again. Uh, we are discussing about the pressure belts of the atmosphere, in which we are discussing how the pressure belt develops. I said at the equatorial regions, you have a high temperature leads to upward vertical rise in the air parcel, which forms a low pressure conditions here. Here you have a low pressure cell. Okay. On the contrary, cold condition leads to sinking of the air at the polar area, which is forming a high pressure cell here. High pressure cell here. High pressure region, sinking of the air. Also, I told you that when from the high pressure region wind blows toward the surface, wind blows toward the equator it is coming, it is affected by two things. It is affected by two things. You know what are those? Number one, first thing is contrast air mass, two different type of air mass. In a region, we have this side cold air is coming, cold air mass it is coming here. This is cold air. Cold air is advancing this side, and this side you have the warm air, less denser warm air is here. This is warm air. This is warm. This is cold. This is warm. So what happened here? This air will move upward. This air will move upward. Because density is less, this will intrude below it, and it lifted up this zone. ये नीचे जाएगा, इसको ऊपर उठाएगा, and this leads to the thrust became now like this. Now it will move in this way. The warm air will move in this way now. ऊपर जाएगा. पहला बात ये है. That is what I said. Thermal contrast of two mass of air, two air mass. So this is cold air, warm air. So I said thermal contrast between the warm and cold air masses, or warm and cold air mass, warm and cold air mass and cold air mass, both warm and the cold air mass, thermal contrast between the warm and cold air mass. While these two air mass meets here, the warm air mass rides up, the cold air mass sink down, मैंने कहा, and this is further, you know, why it will give thrust here. This give thrust from below. क्यों देगा पता है? Why it is? Because I was mentioning one more point, sudden change in the centrifugal force also there. Centrifugal force. How it is? Let me tell you. Let me take two examples here. See, from the center of this, from this center, this is also the center. Okay. This is, here is the Now, you know that here if it is a rounded one, the rate of change in the force, यहां से अगर इधर आते हो ना, gradually it will change, and let us say this is the equator here, up to the equator if it is coming, this is the equator here, okay. So कुछ भी चीज अगर है, force जो है ना, centrifugal force is 0 here, and here it will increase up to the equator, progressively, gradually it will increase. यहाँ पे gradual increase in the सेंट्रीफ्यूगल फोर्स. सेंट्रीफ्यूगल फोर्स कहां ज्यादा होगा? सबसे ज्यादा बताओ तो. रोटेटिंग ऑब्जेक्ट में इक्वेटर में ज्यादा है, क्योंकि रेडियस सबसे ज्यादा है. सी हियर एट द इक्वेटर इट इज मोर, ग्रेजुअल इंक्रीज होगा सेंट्रीफ्यूगल फोर्स, 0 हियर एंड इट इज मैक्सिमम एट दिस प्लेस. नाउ इन दिस केस व्हाट हैपेंड, हियर ऑल्सो इंक्रीज इन द centrifugal force CFG will increase, but not in a gradual, proportionate gradual use नहीं है. Sudden increase at 60 degree, ये 60 degree है ना, at 60 degree north or 60 degree latitude, sudden increase in centrifugal force due to change in its curvature, that is due to change in its shape from a circle to geoid. A geoid shape है ना, अर्थ इज geoid shape. तो सडन चेंज इन द कर्वेचर इज देयर एट दिस पर्टिकुलर 60 डिग्री लैटिट्यूड, सडन चेंज होता है. तो थोड़ा सा कंपैरेटिवली डीट अप, 0 एट द पोल्स एंड मैक्सिमम एट द इक्वेटर. यस इट इज. सो ग्रेजुअली प्रोग्रेसिवली चेंज हो रहा है. यहाँ पे एक सर्किल होता तो, बट इट इज जियोइड शेप. इन केस ऑफ ए जियोइड शेप अर्थ, दिस इज अर्थ इन ए परफेक्ट सर्कल. अगर ये सर्कुलर होता अर्थ इक्वल टू जियोइड शेप है. जियोइड शेप अर्थ में क्या है, एट 60 डिग्री देयर इज सडन चेंज. आपको तो पता है, व्हाइल यू आर ड्राइविंग ए बाइक, यू हैव ए पिलियन राइडर, पीछे एक दोस्त बैठा है आपका. ग्रेजुअली इफ विल इंक्रीज द वेलोसिटी ऑफ योर व्हीकल from 5 to 10 kilometer per hour, 20, 30, gradually if will change, if will increase the velocity, there is no problem. But you are in 10 kilometer per hour and suddenly 120 पे आ गया, क्या होगा? तो बैक साइड द पिलियन राइडर विल फॉल बैक पीछे की तरफ आ जाएगा. yes or no? सेम थिंग हैपन हियर इन दिस केस. ये प्रोग्रेसिवली आ रहा है, मगर यहाँ पे क्या होता है, दिस इज कमिंग here sudden change leads to thrust, sudden change leads to upward movement, like upward jerk of this air mass itself. So that is the cause you are having here. यहाँ पे ये नीचे से thrust देगा, जो बोला ना thrust देगा, ऊपर उठा देगा ये. This is a cause here. Air mass contrast is there, and it is further initiated by, catalyzed by thrust like this. Inertia जो कहेंगे, या sudden change in this case, sudden change in the force may leads to sudden lifting up of the air, and this is the reason for which it moved up. So it is not temperature, it is the dynamic concept, dynamic principle which is responsible. So not the temperature, dynamic factor is responsible for the development of subpolar low pressure. So this is here is subpolar low pressure is developed due to dynamically developed. So ये है आपका, what is the name of this pressure belt? This is polar high pressure belt, polar high. This is equatorial low pressure belt. This is also polar high pressure belt, polar high pressure belt, polar high. Okay. In between, this is here is called as the subpolar low pressure belt. Subpolar low pressure belt is not at all related with temperature, it is related with dynamic factor. ये टेम्परेचर के साथ रिलेशन नहीं है, डायनेमिक फैक्टर है. एंड हियर ऑल्सो सेम वे एज आई सेड, व्हेन इट गिव थ्रस्ट जब देगा तो ये एयर जो हुआ है यहाँ पे लिफ्ट ऑफ हो गया, ऊपर गया, ऊपर जाके ऐसे इट विल गेट डाइवर्ज हियर इन द अपर पार्ट, it got diverged in the upper part. Okay. So at 60 degree there is a rise in the air parcel, then it got diverges here, divergence of the air in the upper part we are having, divergence of air in the upper part. Okay. There is a divergence of air in the upper part, right. Here also, in this case also we have like movement, barotropic, yes of course barotropic कहेंगे. I will not use any jargon word here, okay my friend. So here also you see this is lifting up of the air, and because of this यहाँ से एयर जो है ये ऊपर उड़ जाएंगे एंड ऊपर जाके दो साइड हो जाएगा. मैंने कहा था अभी इट विल ब्रांच अप इनटू टू पार्ट्स हियर ऑल्सो. देखो ऊपर जाके दो पार्ट हो गया. इट मूव्ड अवे फ्रॉम ईच अदर हियर, टू एरियाज. यस. नाउ इमेजिन ए केस, दिस साइड देयर इज मूवमेंट ऑफ द एयर, दिस साइड देयर इज डाइवर्जेंस ऑफ एयर. दोनों साइड अगर होगा तो क्या होगा यहाँ पे, बिकॉज ऑफ दिस डाइवर्जेंस फ्रॉम बोथ साइड व्हाट विल हैपन, ये void space हो गया. बिकॉज ऑफ द void space here there is sinking of the air in this case, sinking of the air in this case. Sinking of the air, and this leads to formation of a high pressure here. यहां पे लो प्रेशर यहां पे है, हाई प्रेशर बिकॉज ऑफ सिंकिंग ऑफ द एयर. सो ये जो एयर सिंक किया यहां पे हाई प्रेशर बनेंगे. दिस इज कॉल्ड एज व्हाट, नाउ दिस इज सब ट्रॉपिकल रीजन 30 डिग्री, सब ट्रॉपिकल हाई प्रेशर बेल्ट, सब ट्रॉपिकल हाई. यू गॉट इट. हियर यू हैव what it is said, this is at subpolar low pressure belt. This is low pressure belt here, subpolar low pressure belt. Here also a low pressure belt, subpolar low. Here you have a low pressure belt, subpolar low. Okay, subpolar low pressure belt, subpolar low. Vertical rise in the air parcel here. Now same thing occur in this side also, you see here, because there is divergence from both sides, there will be sinking of the air. Air will sink, here it forms a complete circular movement here. This is sinking of the air, mean here is development of a high pressure condition. This is a high pressure cell. So it is what type of high pressure? This is subtropical high, subtropical high pressure, subtropical high pressure belt here. Equatorial low, you got the equatorial low here, You got a subtropical high, subpolar low, polar high. You got it now. And remember this particular cell I have different name, like this is called as what? इसका नाम है Hadley cell. Hadley cell. ये सेल हो गया ना, ये भी हो गया क्या? Hadley cell. After this you have here, this is called as Farrell cell. This is here is Farrell cell. Beyond this you have the, what is that? Polar cell. This is here is polar cell here. Polar cell, Farrell cell, Hadley cell, polar, Farrell and Hadley cell. This is another tricellular model. In each hemisphere, this is here is the northern hemisphere. This side you have the northern hemisphere. This here is the southern hemisphere. है ना? This is northern hemisphere. Here it is southern hemisphere. Northern hemisphere and southern hemisphere. What about the air mass at 60° latitude? If you kindly explain it. Definitely I will explain, don't worry. Please explain the subtropical wind movement. Yes, let us do it. Can you just draw this first? I will explain it in another diagram now. इसको प्लीज थोड़े एक बार जो है ना आप लिख लीजिए, बना लीजिए. Please draw this or take a photograph of this one. A lot of things we have to discuss about this now. I'll dictate, we'll write down few points about this, how these cells are developed. I mean, now we'll write down, at that time I'll explain it again one by one. I'll explain it again, don't worry. Done. Completed. I'll go for the next. Can I go for the next? Should I? बनाओ, एक मिनट बनाओ. Please do this first. Hey, I am in side man. Give side क्या? Side तो हूँ. I will explain this again, but I want, please draw this diagram. If drawn completed, please say clear. हो गया, done. So that I will move. Okay. Thank you. So there are two parts, north and south, as I have just mentioned. Let me now again go to this. See here what happened. Here you have, look at very carefully, please look at. Look at here, बहुत easy है, don't worry. Look at here. Here is cold condition, sinking of the air, because the air is sinking here, because of very cold condition, denser air will sink, gravity is also more, high pressure, so here it is sinking. At the equatorial region, high temperature leads to movement of the air northward, right? So this sinking of the air leads to what is the formation of this which belt here? ये यहाँ पे क्या बना? Polar high pressure belt, polar high pressure, here it is, and here you have equatorial low pressure, ये भी equatorial low, right? Now from polar high to equatorial low, wind will blow. To maintain equilibrium, wind blow from here to here. Now nearly at 60° latitude, there is a sudden increase in the centrifugal force, sudden, थोड़ा सा thrust देगा. And this is the wind here. What type of air is coming? Cold air. Cold air is heavy, denser one, and it is blowing towards the equator. Because of sudden change in the force, centrifugal force, it just lifted up like this. So the warm air through which it is intruding, the warm air got lifted up. Warm air got lifted up, so it forms a low pressure here known as subpolar low pressure. Subpolar low is formed due to what? Because of dynamic factor, not due to only temperature. Dynamic factor है, ऊपर उठ गया ये, it moved up. You see now, this part is moving in this way wind, and part of this wind is again going this way because of what? Convectional instability. So both side wind is diverging, when a high pressure is developed and sinking of the air. This is also not related with temperature, rather dynamically produced here. Because of divergence of the air from this side towards equator toward the subpolar region, there is sinking of the air, and this region develop a subtropical high pressure belt. Subtropical high. Sinking of the air is associated with what? Sinking of the air, high pressure. So high pressure, and here is low pressure. Likewise, to maintain equilibrium flow of air, and you have a complete cellular movement, cell like development is there. This is called as the Hadley cell. This one is called as the Ferrel cell, and this one here is called as the polar cell. So we have tricellular model here, 3 cells. Okay. One question I got it. The land mass in more in northern hemisphere and ocean surface is more in southern hemisphere. How come the cells are equally distributed in both the hemisphere? Am I saying that equally distributed? No. You are absolutely correct here that there is unequal distribution, there is modification. We are taking an idealized model. It is a model, it is not the true sense. It is a model. If everything is uniform, then only. ऐसे थोड़ी हो जाएगा. Okay. It is a model, you remember. This is not a correct, 100% correct one. ये मॉडल है, आइडियलाइज्ड मॉडल है अंडर सर्टेन सर्फेस. ये अगर एज्यूम करेंगे, अगर सरफेस समान है, सब कुछ है, तो ऐसे होंगे. देन ओनली दिस विल हैपन. यू गॉट इट? ओके, होप यू गॉट इट नाउ. So there are 3 cells: Hadley cell, Ferrel cell, and polar cell. Hadley cell, Ferrel cell, and polar cell, 3 cells you have. Okay, tricellular model, 3 cell model here. इस cell का पहला Hadley cell कहते हैं, Ferrel and polar cell. My friends, if you got it, say yes. If you have repetition required, tell me, repeat. जो भी है लिखो, please. I want all of should have clarity, because once you got this, believe me, there will be no problem for you in climatology, in air circulation. A lot of things are there related with this only. Entire atmospheric phenomena is related with this. I request again to all of you, if you have any doubts, please. Repeat के लिए बोलना है, repeat के लिए बोलिए. If you haven't got it, and I also request you all, as I said, NCERT basic things, you just study and come. I'm sure you'll enjoy. मजा आएगा. You will definitely get the concept. Believe me, I got the what I got feedback from Kolkata itself. ATI में student, they got clarity on this. I am really happy with this. Even looking at the cloud, the people are saying, sir, this is that cloud. This is what, that type of satisfaction here, really I got it. That's many a time I feel very happy on this. What type of rainfall, किस टाइप का क्लाउड है, क्या रेनफॉल है, कैसा हुआ, बच्चे बताते हैं. I want you should have clarity and you should able to tell your friend even I see this is the case. Okay, I will repeat it again because I got one request, please explain. Or most of you said got it, but one person is here. How Ferrel cell created? Okay, fine, I will do it, no problem. Look at here. Look at here. Sure, I will repeat it. First point is whether you got the difference between a geoid and a circle. In a circle, what happen? Progressively, gradually increase in the centrifugal force will be there. But interestingly, in case of a geoid, because shape is distorted here, this is here is you will get like a sudden change in the shape here at 60 degree. At 60 degree there is sudden change in their shape. $90 degrees south is this. This is the actual shape of the earth. Actual shape of the earth is this one. This is the actual shape of the earth, isn't it? ये circular नहीं है. तो यहाँ पे what happened to this earth here in this case? Here it is distorted in this way. Okay, distortion है because of this. और यहाँ पे देखो there is because of this particular nature what happened here, ये ऐसे चला गया. Polar flattening equatorial bulginess, again I am saying polar flattening and equatorial bulginess. Polar flattening and equatorial bulginess. Polar flattening and equatorial bulginess is there. So 60 डिग्री में देखो सडन चेंज हो रहा है शेप की, इसलिए 60 डिग्री के पास सडनली चेंजेस हो रहे हैं. This is what I tried to explain it to you, the shape between these two. So sudden change in this leads to here, you know, जो सडनली अगर कोई वेलोसिटी बढ़ जाता है तो आप ऐसे ऊपर उठते हो ऐसे है ना, velocity is like this, so it is moving in this way and there is lifting up of this. So ये अगर lift कर दिया, for that reason you know the air above this will get lifted up. warm air था जो ऊपर उठ गया. This is what happened here. So cold air from the polar area, this is polar area, polar region, this is here is temperate zone from which it is coming, this is cold air, this is warmer compared, little lifted up. And this leads to formation of a low pressure condition here. So that is what I said. Look at here. Here the air is sinking at this point because of high pressure condition and going toward the equator at the 60° latitude is lifted up, forming a low pressure. So it is, while it moved up, vertically moved up, it in the ground what happened? Wind from both sides will come and converge and move up. So in this way it moved up here, forming a low pressure condition known as subpolar low. Subpolar low here. Again there is a complete, because of subpolar low you have a complete polar cell here. And this moved upward here, same way. देखो यहाँ पे subpolar low में ऊपर गया. Here you have equatorial part. Equatorial part it is going upward. So wind is blowing from the middle part 30 degrees से इधर toward the equator as well toward the subpolar area. Both it is diverse. Surface पे ऊपर क्या है? Divergence is there. Because of this divergence, sinking of the air you have. void हो जाएगा ना. दो लो प्रेशर के बीच क्या होगा? हाई प्रेशर ही होंगे. So between both sides the wind blows both sides, middle void space to fill up this air will sink and it forms a complete cycle here known as Ferrel cell. This wind goes in this way towards the equator and it forms a complete cycle again known as the Hadley cell. Hadley cell ऐसे बनेंगे. Hadley cell, Ferrel cell and polar cell. 3 cells they will develop in this way. Right? So these 3 cells are called as the tricellular. देखो यहाँ पे, here it moved upward, here it is sinking of air, यहाँ पे sink कर रहा है air, इधर पे ऊपर जा रहा है. And while it is going here, it is going up, low pressure here. Now drag air from this side and this side. This is low pressure because of equator. This is equatorial low. This is the equatorial region. So air is moving here upward vertically because of what? Cold, high temperature. Wind blowing in this way, in that way. So sinking of the air known as the high pressure here. Which high pressure? Subtropical high pressure. So in this way we have 6 pressure belt we got. 6 pressure belt we got. Finally we got 6 pressure belt. 6 pressure belt हमें मिल गया है. Is it clear to all of you? Now is it clear? Those who said repeat and please explain again, please, have you got it? If you got it, I will go for the next. Yes, tell me. Done. See, whatever the best possible way I tried. Why cold air mass from pole will rise since it is a cold air? Who will say that cold air is rising? Look at here. मेरा ये कलर देखो, इसका इसका कलर देखो. Warm air is rising here. And let me tell you again, whoever you, if you are not, I think, see, inside the classroom or wherever you are studying, remember, only you and me, nobody else is there. आप मोबाइल को या जो भी आप बंद करो, सब concentrate करो, whatever I am saying. Believe me, you will get it. Don't divert your attention. Concentratedly give me that 2 + 2, 4 hours here. Come on, for your career. We all are here, your friend. You are not your enemy. तुम्हारा आसपास जो है ना वो सब एनिमी हो सकता है. दे आर कॉम्पिटिंग. द टीचर हियर इज योर फ्रेंड. यू रिमेंबर वन थिंग, आपको हेल्प करने के लिए हम आए हैं. Remember that and study sincerely. If you are not helping yourself, you will not indulge. If you will not study and come, you will not get it. Very basic things you are saying. Nothing, कुछ भी नया नहीं है. बहुत ही very basic, fundamental thing I am saying. Take the positive things, whatever is there. हो सकता है आपको कुछ परेशानी हो कहीं पे, बताओ वो परेशानी हमें डायरेक्टली. If you are not getting, but I am sure if you are bit of attentiveness, if you have, you must have got it. Why cold air from pole will rise? Who said the pole air? Cold air is coming in this way. ये यहाँ पे ट्रांसफॉर्म हो जाएगा धीरे धीरे करके. That's why cyclone develop here. Cyclonic disturbances is there. Okay. Cyclonic, cold and warm air mass meets and cyclone they develop. Okay. It is lifted up, I said. Force ज़्यादा रहेगा तो थोड़ा सा ऊपर thrust देगा. Right. It will give some thrust to this. कहाँ पे cold air को उठाया? देखो यहाँ पे cold air नीचे जा रही है, warm air उठ रहा है. ठीक है. And this is here is there. Please look at carefully, please. Okay. Now let me move on to the next. Pressure belt of the earth. Let us now see. I think it is clear now, my dear, who asked about the cold air mass. Clear? Okay. I said there are seven pressure belts. Seven. Pressure belts. There are seven pressure belts in our atmosphere. There are seven pressure belts in our atmosphere. What are those? Number one is equatorial low. Number two is subtropical high of northern hemisphere. Number three is subtropical high of southern hemisphere. Fourth one is subpolar low of northern hemisphere. Fifth one is subpolar low of southern hemisphere. Then sixth one is polar high of northern hemisphere, and seventh one is polar high of southern hemisphere. There are seven pressure belt, I said. This pressure belt here is at 0 degree latitude. This is 30 degree north, 30 degree south, 60 degree north, 60 degree south, 90 degree north and 90 degree south. Okay. See here. Seven pressure belts in our atmosphere. These are the seven pressure belts I said. Equatorial low, subtropical high of northern hemisphere, subtropical high of southern hemisphere, subpolar low of northern hemisphere, subpolar low of southern hemisphere, polar high of northern hemisphere, polar high of southern hemisphere. Seven pressure belts. Total atmospheric circulation is greatly influenced by these seven pressure belt. These seven pressure belts. I hope it is clear. Total atmospheric circulation is influenced by these seven pressure belts. These seven pressure belts only. So let us look at each of them in detail now, because you haven't written, you got the concept earlier. Now I want you all to write something also. Please write. First is equatorial low. Equatorial low pressure belt. First one, it developed due to high temperature and consequent convectional instability. It developed due to high temperature and consequent convectional instability. Okay, first point. So it is thermally direct. It is thermally direct. मतलब because of the high temperature it has formed, so it is thermally direct. Okay. Which develop, ये क्या develop करता है? This leads to the development of what? This leads to the development of the Hadley cell. It helps in the development of the Hadley cell. Hadley cell. The Hadley cell was developed because of this only. The Hadley cell is developed due to the equatorial low pressure belt. Part of the Hadley cell it is. I told you how it developed. I think it is clear to all of you. Right? Let me now again, second one. Second pressure belt is, second region, subtropical high pressure belt. Okay. It is a dynamically developed pressure belt. It is a dynamically developed pressure belt. Okay. It is a dynamically developed pressure belt. How they develop and what is there, let us see now. It is a dynamically developed pressure belt. मतलब there is no direct impact. That is, it is not thermally direct. Right? Next one. Due to the divergence of wind or air towards the equator or equatorial low and towards the poles, toward the pole, that is subpolar low. This pressure belt form. This pressure belt formed. Finally, this pressure belt formed because of these two causes. I hope you got it now. Due to the divergence of air towards the equator and towards the pole, this pressure belt is formed. Okay. See here, as I just have mentioned about this, divergence of the air towards equator, and here equator and toward the poles, here toward the poles it is, that is subpolar low. So that's why, you know, where you have divergence leads to sinking of the air and formation of high pressure. So this divergence leads to, due to the divergence of the air due to the equatorial line towards the poles, this pressure belt form as a result of sinking of air to maintain equilibrium, sinking of air to maintain equilibrium, sinking of the air to maintain equilibrium, you have like this. Due to the divergence of air towards the equator and towards the poles, this pressure belt formed as a result of sinking of the air to maintain equilibrium. I hope it is clear. One of the very, very important, this particular belt, pressure belt. Let us now look at the next, third one. Third one I will go for the subpolar low pressure belt. Both in the northern and southern hemisphere you will find this. It developed due to the dynamic factors, not the thermal factors, it is the dynamic factor. Okay, put comma and note down here that air flows towards from a cold air, cold air blows from the poles towards the equator, towards equator, due to or to maintain equilibrium, but at nearly 60-degree latitude, what happened here? At nearly 60-degree latitude, the cold air mass intruded over the warm air mass and lifted up due to variation in its density, due to variation in its density. Okay, there is density variation, that's why it happened. It is further strengthened due to sudden change in the centrifugal force at nearly 60° latitude. Okay, this is further strengthened. I am going to lifted up, further strengthened, lifted up due to this, and this leads to again the development of a low pressure cell. This will develop finally a low pressure cell. Is it clear? This will develop finally a low pressure cell. Yes or no? It is further strengthened due to the sudden change in the centrifugal force at nearly 60° latitude. Clear hai? Okay. Now I will move for the next. Next one is your polar high pressure. Polar high pressure. Polar high pressure belt. Thank you. See, be in touch, whenever you are not getting, please let me know. It's a very simple thing, yeah. Come on, once you get it, it will be forever and very easy to get if you study. Concentrate here. Polar high pressure. Why they develop? I told you, because of cold polar wind. Cold polar area which associated with sinking of. The polar region is associated with very cold condition and gradual very cold condition and more gravitational force than the equator. More gravitational force than the equator. Also there is another point, with the earth rotation there is whirling of the wind and sinking of the air. ये भी एक है. And you know about polar vortex. Polar vortex also a term, polar vortex. I request you all to see whatever online, if you will get anything about the polar vortex. क्या बोला मैं? You watch this because you people are very smart people. Smart लोग हैं आप लोग, देख सकते हैं. You can see, watch the video of polar vortex. I will also show you later on whenever it is. But you see the polar vortex. Videos are available online, you can see that. My friends, you will be surprised to see how the earth is moving and subsequently air is sinking from that particular polar upper part of the pole. This is the pole here. Here like sinking of the air, it is sinking below. From here it is sinking and going like this, sinking of air, sinking of air, sinking of air, sinking of the air here like this. Very interesting here. This is here is the polar region is associated with very cold condition and more gravitational force than the equator. Okay. So what happened here? Sinking of air leads to the development of a low pressure, high pressure zone. High pressure zone called as the polar high, called as the polar high, polar high, polar high pressure, polar high here, called as the polar high. Okay, it is called as the polar high pressure. So, polar high is thermal relative temperature. So, its origin has thermal factor, मतलब temperature as a factor, cold condition, thermal factor mean temperature as the factor, major factor. Thermal factor mean here temperature as the major factor here. Thermal factor here means temperature plays the most important factor here in this. Okay, fine, done. So these are the 7 pressure belt of the earth. ये जो 7 pressure belt है, my friends, now look at here. I'll just draw this 7 pressure belt now. These are the 7 pressure belts. These pressure belts which I have drawn now, I will show you what is the beauty of this. Okay, क्या है? These pressure belt are related with what? So we got 2 low pressure here, you know it, 3 low pressure, total here 3 low pressure condition. Sorry. This is the high pressure here. Let me write down. This is as the high pressure condition here. This is the high pressure condition. Here is a high pressure condition. Here is a high pressure. Here is a high pressure. Okay. Now, this is number 1. Number 2, 3, 4, 5, 6, 7. 7 pressure belt. Can you please name me 1, 2, 3, 4? Without referring your register, can you write 1, 2, 3, 4? आप register अपना मत देखिए और बना के भेजिए. Send it to me. 1 represent what? 2, 3, 4. Okay? 1, 2, 3, 4. and if anyone can write 5, 6, 7 also. In between you have some low pressure also. This is here is a low pressure. Here you have a low pressure. Here you have a low pressure. So total 7 pressure belt you have. Total 7 pressure belt you got. लिख के दो, बनाओ, देखता हूँ how we have done. Once you got this 7 pressure belts, you got it. One represent what? Without referring your atlas, your book, without referring your notebook. So you have, as you people said, this is the equatorial low pressure belt. This is the subpolar high pressure belt. है पक्का है? I haven't got any answer from you. That's why I am writing like this. Can you see that? Yes? बोलो. एक भी कोई आंसर नहीं भेजा. 1 and 7 polar high, okay. 2 and 6 subpolar low. 3 and 5 subtropical high. 4 is tropical low. Tropical नहीं, equatorial low. You can note that equatorial low, okay. Very good, very good. चलिए, thank you. I just want anyone who has done wrong. No, nobody. Thank you very much. Whatever answer I got it correct. Thank you. So it is the polar high, subpolar low, subtropical high, equatorial low. Subtropical high, subpolar low, and you have here polar high of southern hemisphere. Thank you very much. You people has done well. So याद हो गया आपको. You are now remembering the things. Thank you. Now, my friends, air will blow from where? From the high pressure to low pressure, and this is called as what? Wind. Air will blow from high to low pressure condition. This is called as wind. So the air will blow from high to low mean क्या होगा यहाँ पे देखो. This will blow from here like this. ऐसे होना है ना, high to low. And this will be from here to here like this. From here to here like this. From here to here it will be like this. High to low ऐसे होगा, high to low ऐसे होगा. Yes or no? ऐसे होना चाहिए. To maintain equilibrium, the wind will blow in this direction as I have shown. Yes? To maintain equilibrium, wind will blow in this direction. Correct? To maintain equilibrium, the wind will blow. But very interesting thing happens. Very interesting thing happens. It will not go straight. It will not go straight, rather there is, in this case what happened? Change in the direction of the wind takes place. Why and how? Why tomorrow I will discuss, but how I will go for now. Okay. It is because of the earth rotation and there is a force known as Coriolis effect. क्या बोलते हैं उसको? Coriolis effect. Okay. So अकॉर्डिंग टू दिस लिखो यहां पे, अकॉर्डिंग टू द फेरेल्स लॉ, फेरेल्स लॉ, मैं आगे बताऊंगा क्या क्या है, टुमारो विल हैव दिस, बट अकॉर्डिंग टू द फेरेल्स लॉ, wind diverts from its normal path towards right in the northern hemisphere and left in the southern hemisphere. Again, according to the Farrell's law, Farrell's law, wind diverts from its normal path towards right in the northern hemisphere and left in the southern hemisphere due to the Earth's rotation and Coriolis effect. Coriolis effect. What is that Coriolis effect? आपने कभी मेरी गो राउंड में बैठा है? मेरी गो राउंड ऐसे घूमता है, आज बैठ के देखो, 2-3 friend of yours, and while it is static, you throw a ball towards your friend, सामने में जो है वो कैच कर लेगा, मगर while it will be in a rotating position, ओके मैं कह रहा हूं क्या, देखो यहां पे, यू आर सिटिंग हियर इन दिस, ओके, ये मेरी गो राउंड है, आप यहां पे बैठा हुआ है, here is A is here, let us say, B, C and D, 4 people are there. You throw a ball towards this, यहां से आप क्या करेंगे, you throw a ball towards A to B, आपने थ्रो किया बॉल, ओके, बट इंटरेस्टिंगली ये सीधे इट इज नॉन रोटेटिंग में ऐसे होगा, बट द मोमेंट आई रोटेट इट लाइक दिस, मैं अभी क्या करूंगा, ऐसे रोटेट कराऊंगा इसको, नाउ इफ आई थ्रो द बॉल, ये जो बॉल जो जाएगा ना इनके पास, ऐसे जा रहा है, इट विल हैव कर्वेचर, इधर पे आ जाएगा, इट विल कर्व रिकर्व एंड इट विल लाइक यहां पे आ जाएगा, हाँ होगा क्या, ये बी के पास आ जाएगा, ये डी के पास, you are throwing the ball straight but D will capture that. करके देखो आप, दिस विल, बिकॉज एट दैट टाइम, इस टाइम तक क्या है कि आप C का डिस्प्लेसमेंट जो है ना, यहां पे C का जगह पे यहां पे कौन आ गया है, D आ जाएगा, इसी पोजीशन को आप करके देखना ये, you do this एक्सपेरिमेंट आज और बताइए कल. And tomorrow again I'll show you some videos on this. Those who are completely new are not knowing the things properly. देखेंगे. मगर एक चीज है, if I'll now opposite way if I'll do, then B will get the things. If I'll rotate it in the opposite way, let us say मैं अभी ऐसे रोटेट करता हूं. If I'll rotate in this way, now it will come to B. A B के तरफ आ जाएगी. B के तरफ आ जाएगा. It will be towards the B. Now what it happen? If it is static, directly A to C जाएगा. अगर ये पूरी तरह से स्टैटिक है तो A to C सीधे जाएगा. अगर इसको घुमा दिया राइट की तरफ जाएगा. इस तरफ घुमा दिया राइट की तरफ, उस तरफ घुमा दिया, देखो आप, in the opposite direction if I'll do. Got it? Now this is the cause, you know, we have this force. Tomorrow we will discuss how it is. But if it is true, let us say, अभी हम प्रूफ पे नहीं जाएंगे, देखते हैं अगर ये सही है. ये क्या बोल रहा है? According to the Farrell's law, already it was proved by Farrell's, Charles Farrell's. Wind diverts from its normal path towards right in the northern hemisphere and left in the southern hemisphere due to the earth rotation. With the earth rotation and Coriolis effect. Due to the earth rotation and Coriolis effect. Due to the earth rotation and Coriolis effect. ये अर्थ की रोटेशन और कोरियलिस इफेक्ट से होगा. ये प्राइमरली बिकॉज ऑफ द कोरियलिस इफेक्ट एंड द अर्थ रोटेशन. मैंने कहा ओके, बहुत इंपॉर्टेंट है ये, याद रखें. सो विंड अगर इफ विल एग्री विथ दिस, let us accept this, okay? If it is true, let us it is true. अगर ये सही है, let us say here the pressure is 1000 millibar, 950 millibar, 900 millibar, 900, 950 and 1000 millibar. If it is like this, this is a what? Then it is a high pressure cell. Yes or no? Now if it is a high pressure cell, here the wind will blow from inner part to the outs. Inside से out की तरफ जाएगी. ऐसे जाना है, सो इट विल टर्न टुवर्ड्स 1 और 2. किधर जाएगी? सीधे जाएगी. मैंने कहा कि इन द नॉर्दर्न हेमिस्फीयर टुवर्ड्स राइट, इन द सदर्न हेमिस्फीयर टुवर्ड्स लेफ्ट, ये बता रहा है. मेट्रो में जाओ ना, कोलकाता मेट्रो में गति की दिशा में दाहिने तरफ खुलेगी दरवाजा या बाएं तरफ है, देखा है कभी? और दिल्ली मेट्रो, एनीवेयर एट द फ्लो डिरेक्शन, फ्रॉम द फ्लो डिरेक्शन टुवर्ड्स राइट और लेफ्ट. So at the flow direction towards right, 1 or 2, please reply immediately. Northern hemisphere, it will divert from here, it will divert towards 1 or 2. 1 or 2, किधर जाएगा? बताओ. Which side it will divert? ये हवा बाहर आना है ना, 1000 millibar to 900 millibar. It was supposed to come out, now turn towards 1 or 2. Yes. Which side it will divert? टू, पक्का? अरे वाह. नॉर्थ 2. Why not 1 यार? हाँ, वेरी गुड, वेरी गुड. थैंक यू वेरी मच. आप तो यार मेरे को पूरा खुश कर दिया भाई. थैंक यू वेरी मच. Thank you, thanks a lot. I mean, now I'm sure you are getting the things. Thank you, proud of you. Thank you. Now towards right. Yes, great, that's great. Towards right. Absolutely correct, absolutely correct. Thank you. हो गया. I got it. Thank you very much. So towards right it got diverted. Now you tell me here it will towards 1 or 2 or A or B. A करता हूँ. A or B, which side? A or B? अभी एक और पूछ लेता हूँ. A or B? Here it will turn towards 2. Here it will towards A or B. यहां पे A की तरफ जाएगा, B की तरफ जाएगी. A, very good, very good. A. टर्न टुवर्ड्स ए, यानी कि सबको आ गया है. अरे वाह. नॉट ए सिंगल एरर, ऑल ऑफ यू आर करेक्ट. थैंक यू वेरी मच. देन आई कैन एक्सपेक्ट समथिंग फ्रॉम यू. नाउ हियर इट वाज सपोज टू गो टुवर्ड्स दिस, but it will divert towards X or Y. It is very easy, is not it? ये तो सब कर लेंगे. All of you will do. It will turn towards X or Y. Okay. Same way, here also it will see, if you will see here, it will turn towards right here. Got it? See, if it is a high pressure condition, if it is a high pressure condition, you are getting oh, very good. All of you have given right answer again. You see here, it's like this. So high pressure is clockwise or anti-clockwise here? So high pressure circulation is clockwise or anti-clockwise? ऐसे जा रहा है ना, clockwise in northern hemisphere. They are clockwise in northern hemisphere. They are clockwise in northern hemisphere. Yes, they are clockwise in northern hemisphere. If hypothetical the air 59 degree north is certainly hotter, therefore lower in pressure than air at 60 degree north, how is the air from 59 degree north going to feel in the subpolar low pressure zone at 60 degree north? I think now you got the question. If hypothetically the air at 59 degree north is certainly hotter and therefore lower in pressure than the 60 degree north, hypothetically how? Acha, okay. Then how is the air from 59 degree north going to feel in the subpolar low pressure zone at 60 degree? My friend, here it will be hotter, no? It will move up. It will move up. ये ऊपर जाएगा ना? Because once it move up, mechanical instability will have. क्या बोलते हैं उसको? Mechanical instability. One of your friend asked me, if hypothetically the air at 59 degree north is certainly hotter. Yes, it is hotter. And therefore lower in the pressure. Yes. Then the air at 60 degree north, how it is air from 59 degree north? Philip, you see that this side it is coming, so density is less. So it will already ये तो hot है और this is like lighter है. It will give pressure, I said. That is also a cause. And second thing I said, sudden change in the centrifugal force. मैंने बोला ना आपको, it will lift it up. Vertically if it will go up to fill up the gap, there must be air from nearby surrounding regions. So कहाँ से आएगा? Toward the lower latitude area it will come. That is from which region? Again, this will be from the subtropical high pressure. उसी रीजन से आएंगे, तभी तो बनेंगे ये. आप थोड़ा कनेक्टिविटी को देखो. एंड आई डू रीड दिस एनसीईआरटी क्लास 11 बुक. आप ठीक से पढ़ाई करें एनसीईआरटी क्लास 11 फंडामेंटल्स ऑफ फिजिकल ज्योग्राफी एंड बिलीव मी यू विल गेट इट. कुछ नहीं है इस पे. एंड मुझे फिर आप इफ यू आर एनी प्रॉब्लम यू कैन व्हाट्सएप मी एग्जैक्टली व्हाट इज दैट प्रॉब्लम. ओके, whoever you may be, my dear, you have asked me this question. Thank you very much. Let us now move on to this. अगर ये हुआ high pressure circulation is clockwise in northern hemisphere. Now in southern hemisphere what will be? देखो how it will be. If it is like this, here I am giving you 1 and 2. किधर घूमेगा ये? Southern hemisphere. In southern hemisphere towards left. Southern hemisphere towards left I said. So here 1 and 2. किधर जाएगी? Which side it will go? 1 and 2. 1 and 2. So definitely I hope all of you got it, that it will divert from normal path towards 1 left. Here also it will go in this way, here it will move in this way and here it will move in this way. एक कैसा है? क्लॉकवाइज है, एंटी क्लॉकवाइज है. So you can write down here that high pressure circulation in southern hemisphere is clockwise or anti-clockwise? It is anti-clockwise. Anti-clockwise. High pressure is anti-clockwise in southern hemisphere. It is anti-clockwise. Right, done. Yes, thank you. So if it is there, like it is anti-clockwise circulation here. But let us say, I hope it is clear. In this case, I will go for, this is a low pressure here, low pressure here. I mean, let us say here it is 900 millibar, 950 millibar, 1000 millibar. Here also 900 millibar, 950 millibar, 1000 millibar. In this case, what will happen? In this case, there is a possibility, that the air is supposed to, आप यहाँ पे देखो, from the above you are looking at this surface को देख रहे हैं हम लोग, ऊपर से देख रहे हैं, from above, remember this is, from above you are looking at this, you will find like this. Now if in this case, if I will say wind is blowing in this way, ऐसे आ रहे हैं ना, towards center, मुझे बताओ यहाँ पे 1 और 2 में किधर जाएगी? Here 1 और 2, right hand side, definitely the wind will blow from normal path towards right, mean ऐसे होगा, towards right mean like this, towards right mean like this, ऐसे होगा कि नहीं? जाना था कहाँ? राइट को ये घूमेगा, it will have like this. So overall if you see from above, आप देखो ऊपर से ये ऐसे आ रही है, okay. So we have overall circulation here is what is clockwise or anti-clockwise. So you can say here that low pressure circulation is, ऐसे जा रहा है, मीन clockwise एंटी क्लॉकवाइज, एंटी क्लॉकवाइज, एंटी क्लॉकवाइज in which hemisphere? Northern hemisphere. Northern hemisphere it will be anti-clockwise, is not it? Northern hemisphere it will be anti-clockwise. Now here also it is supposed to go in this way. But if I will get X and Y, it will turn towards which side? Left side, like this, X. Is it correct? Left side. But I have given a wrong thing here, have you seen this? Low pressure to high pressure, wrongly I have marked here certain things. Can you see that? Can you identify what is wrong in this? Can you identify what is wrong in this? देखो ये ऐसे नहीं होना चाहिए ये. What happened here? There is a wrong thing here. Like I have marked it, it should be inside. अरे लो प्रेशर है ना, लो प्रेशर में अंदर को आएगा ना ये, it should come inside. ये inside होगा ना, this is here is, it should come inside. ऐसे आना है. ओके. Now here it will turn towards, यहाँ पे लेफ्ट के तरफ है तो इधर आएगी, लेफ्ट को इधर आएगी. लेफ्ट इज लाइक दिस, लेफ्ट इज लाइक दिस. आई होप यू गॉट इट. So overall circulation if you'll see is like this here. I mean it is clockwise or anti-clockwise. In this case it is clockwise. Low pressure circulation is clockwise in southern hemisphere. Low pressure circulation is clockwise in southern hemisphere. Can you just see these things and tell me if you got it? ये चारों क्या आपको समझ में आया? Is this four you got? Have you got these things? ये चारों क्या समझ में आया क्या आपको? Believe me, if you have you got this, आगे हमें कोई प्रॉब्लम नहीं होगा. We will not face any problem in future in the wind circulation and all. So look at here how the wind pattern of movement, if you will see how it is. All of you got it? Any problem for anyone? Anyone have any problem? Okay. Once it is there, low pressure circulation is anti-clockwise in northern hemisphere, low pressure circulation is clockwise in southern hemisphere here, anti-clockwise in northern hemisphere clockwise. High pressure circulation is clockwise in northern hemisphere, high pressure circulation is anti-clockwise in southern hemisphere. Now my friends, you remember all the high pressure here, all the high pressure जितने भी है, all the high pressure in the northern hemisphere or anywhere, all the high pressure are called as anticyclonic conditions. So anticyclone is it is known as anticyclone. Okay, अब देखो यहाँ हाई प्रेशर को क्या कहते हैं? हाई प्रेशर कॉल्ड एज एंटीसाइक्लोन बिकॉज यू हैव ए low pressure is known as क्या है? Cyclone. If low pressure is cyclone, high pressure is anticyclone. Okay, high pressure is anticyclone. So anticyclone is here, and low pressure is here is a cyclone. Cyclone are the low pressure conditions. Two things here: low pressure and high pressure. You have low pressure and high pressure. My friends, if it is true, so all the cyclones they in the northern hemisphere, they rotate in which spiraling rotation will be in the anti-clockwise. सब साइक्लोन जो है ना एंटी क्लॉकवाइज घूमेंगे इन नॉर्दर्न हेमिस्फीयर. इन सदर्न हेमिस्फीयर दे आर इन ए क्लॉकवाइज मैनर. मैं एक छोटा सा एग्जाम्पल देता हूं. लेट मी टेक दिस बॉटल. Hey, don't divert now about polar vortex. Polar vortex, we will have polar vortex related discussion. I will do I'll go for El Nino, La Nina and all. Polar vortex, we have a special discussion on this. Cyclone, while I'll go for this, okay. Please stick up to this which you are discussing now, or at the end I'll answer your question. Look at here. This is, here is a bottle. I'll make a hole here. एक छेद कर देता हूँ. The person who asked me about can we say polar vortex helps in forming ice caps in polar region, have to answer this question, okay. आप पहले आंसर दो मुझे. क्या आंसर है? लेट मी टेल यू. इफ आई विल पुट ए होल हियर, यहाँ पे होल कर देता हूँ, एंड वाटर इज देयर, एंड देन वाटर विल ड्रिप फ्रॉम हियर. सो देयर विल बी सर्कुलेशन हियर ऑन दिस वाटर बॉटल इटसेल्फ. व्हाट टाइप ऑफ सर्कुलेशन? इफ आई विल कीप इट हियर इन दिल्ली और कोलकाता, कोलकाता में अब करते हैं तो किस टाइप का सर्कुलेशन? क्लॉकवाइज और एंटी क्लॉकवाइज? टेल मी. इन दिस बॉटल द वाटर विल सर्कुलेशन विल बी क्लॉकवाइज और एंटी क्लॉकवाइज? यस मैन. Anyone or who is the, please, जो भी है आप आंसर दीजिए. अच्छा, बाकी लोग भी आंसर दो. Others also eligible for this. Yes, tell me. My question is very simple. Very simple question I asked. I said in this bottle, I pierce this bottle and a hole I will prepare, a hole. So because of which water will come out here. So there will be a circular movement of this bottle here. Inside this bottle you have circular movement of water you will find. Clockwise or anti-clockwise? At Delhi I am saying. Clockwise. Why clockwise? Why clockwise? देखा आपने गलती बोला, गलत बोला ये. इट शुड बी एंटी क्लॉकवाइज. कन्वर्जेंस ऑफ, अरे सोचो तो, दिस इज अ व्हाट टाइप ऑफ प्रेशर? लो और हाई प्रेशर होगा ये. एट द मिडिल यू आर पियर्सिंग वन, दैट्स व्हाई व्हाट इज देयर, लाइक एक होल बना रहे हो तो पानी, वाटर विल कमिंग आउट. आई मीन ड्यू टू व्हिच convergence of this water will takes place. Convergence is low pressure. So low pressure in the northern hemisphere is clockwise है. बताओ, only one person said anti-clockwise. Then you haven't got it properly. You didn't able to imagine the case. Anyone? Yes. Low pressure. The wind direction shown in the low pressure northern hemisphere is wrong because it is anti-clockwise, then the direction is wrong. My friend, look at here. I said entire system as a whole you see now. एंटायर सिस्टम एज ए होल यू सी, ये ऐसे जा रहा है थोड़ा, ये तो ओवरऑल सर्कुलेशन ऐसे हुआ कि नहीं? ये क्लॉकवाइज है क्या? माय फ्रेंड हु आस्क्ड दिस, द विंड डायरेक्शन शोन इन द लो प्रेशर नॉर्दर्न हेमिस्फीयर इज रॉन्ग because if it is anti-clockwise then direction is wrong. How come it is wrong? See here, it is going like this is going like this. Entire system as a whole, सिस्टम है, ये ऐसे नहीं घूमेगा, ये यहाँ पे लो प्रेशर नहीं है, ये हाई प्रेशर है, देख रहे हो, ये थोड़ा सा डाइवर्ट हो रहा है, थोड़ा सा डाइवर्ट होगा. सो इट इज लाइक दिस, द रोटेशन, ओवरऑल रोटेशन विल बी हियर एंटी क्लॉकवाइज. सी द एंटायर सिस्टम. नहीं विजुअलाइज कर पाए हो आप, आई एम श्योर नाउ यू आर अनेबल टू comprehend the things properly. Think it again. entire system है जो ऊपर से देख रहा है, we are looking at from above. See these things how it is, gradually it is going like this. All look at the central part, okay, and tell me how it is. Look at the central part and tell me. साइक्लोन नहीं पढ़ाया हूं, साइक्लोन में बताएंगे आपको how it moves. Okay, how it moves. And I request you all to read NCERT. आज ही जाके देखिए. Today itself you see. Kindly look at that. Also the page number 110111 of G.C. Leung book, Go Cheng Leung. 110, I am saying again page number 110111. 110 particularly. And your NCERT also, see the wind system, you will get to know. Do study this. आप ये सिस्टम ऐसे होगा, here it is system will be like this. Somebody is very interestingly written something, you see that's our hot and humid climate in Kolkata. Yes, northern hemisphere has warm air which cause low pressure and it is anti-clockwise. You are here absolutely correct. Thank you very much. पूरा अप्लाई कर दिया भाई आप तो. This concept is now applied. Thank you very much. Thank you. आगे cloud पढ़ाएंगे ना, and cyclone and all. You will see in the cloud even you will feel like, what type of cloud is there? Why this type of cloud? What type of rain it will bring? You will have that confidence. Don't worry. Thank you very much for your right answer here. But my friend who asked me earlier, जो पहले क्वेश्चन पूछा, who said that picture is wrong, picture is not wrong here, diagram is correct here, please look at, find out the concept. I said from above if you see overall circulation, this entire region is as a system, पूरे एक system का लो, ये entire is a system here, then you tell me it is clockwise or anti-clockwise. It will be anti-clockwise. Same way, it entire system को you have to take here. Then only it is a clockwise होगा. Hey, control your emotion. Yeah, who is this? Why cyclone is formed only in ocean? We will come to that. Cyclone topic we have. Special topic. I will spend one session on cyclone itself. Don't worry. मजा आएगा, ये तो है, पक्का है. You will feel, and you will get to know how the cyclone develops and what exactly are the component of this. You will find. Right. Now, let me apply this now. यहाँ हम apply करते हैं अभी. बताओ. Here, this where it will go, 1 or 2? बताओ पहले मुझे. Here it will go towards 1 or 2. Please, all of you are here requested to answer here, 1 or 2. Where it will move? And here you will get A or B. Here I will say X or Y. बताओ. 1 or 2. First, tell me towards which side it will blow. One. चलिए ठीक है. Okay, fine. 1. Now next. This will, fine, very good, 1. Now A or B? Tell me this. A or B? B. Okay. Thank you. B. Very good. Now here I will say X and Y. You said X. X X, all of you X. Oh, thank you. X. See, like the earlier one, toward this side only. Thank you. Thank you. Here it will be towards M or N. M or N. Which side? M or N? Which side it will blow? Towards M or towards N? In this case, towards M or towards N? Okay, very good. So it is M. Towards M. Very good. Now here it is P or Q. Towards P or towards Q? P or Q? Which side it will turn towards P or Q? Q, left side. Thank you. Thank you. Very good. And towards you know about this, that here towards 5 or 6, which side it will go? Towards 5 or 6? This will turn towards 5 or 6? Five or 6? See, it is equivalent to this one. Towards 5. Very good. So it will blow in this way. There 5. So the wind total global circulation. Thank you very much for participating. Thank you very much. Now, global circulation is associated with this. I will explain you the naming of this one tomorrow. Tomorrow I will go for explaining this and let you know about the impact of this particular wind system over the entire planetary climatic types and all lot of things we need to discuss. Some of you asked me about the heat budget we will discuss. The thing is, I request all of you to at least first read the NCERT. NCERT का जो chapter से पढ़ लो. We will do this, don't worry. First NCERT, okay? Do this. Is it okay? Now give me question, whatever you have, please. Go ahead with your question. Whatever question you have, please give me questions. So I will discuss about this from tomorrow. From this point only I will discuss. I will save this file and we will see tomorrow. Okay? कल हम डिस्कस करेंगे यहाँ से ही. मैं रिक्वेस्ट कर रहा हूँ आपको कि कोई क्वेश्चन है, प्लीज गिव मी एनी क्वेश्चन इफ यू हैव. And I hope that you will study and come tomorrow for the entire discussion session. It will be very much interesting if you will participate. I am thanks to you all that you people participated and really very nice. You people have studied, doing well. Thank you very much. Any question? Any question? Any question from your side? Yes. अच्छा, वो जो क्वेश्चन दिया है आपने रिगार्डिंग दैट things, you know, I'll discuss in appropriate time, please. I'll discuss all this. जो question दिया है ना previous year paper and all, I have to explain some more things, in fact related things. So I am just holding few of the question we have asked earlier. So I have noted it, I have filed it. We will have a discussion whenever that particular topic will come. मैं आपको एक हीट बजट का बात है, उसके बाद हीट बजट में आपको ये वाला जो बताएंगे. देयर आर फ्यू थिंग्स, few are there in global warming, urban heat island on that time. So they are related topics. So I am holding this because the explanation will not get to everyone. Maybe you may get these things because you have studied. So that's why I haven't answered. I'll answer this whenever needed at appropriate time. Okay. Is it okay? Thank you very much. There is no question here. So what is meant by dynamically developed pressure? I mean, if temperature is not the only factor, other factors are there due to relative presence of two different pressure belt, or relatively some other things is there, then only. Okay, again I am saying it is not related with temperature. Other than temperature is dynamic because of the movement of the earth due to the comparative pressure gradient between two areas and all. Is it applicable for any river hole? Also water is immersed down? Yes. This is also there. Because of that, you know, in the right in your northern hemisphere, most of the river bank has more erosion because of in the northern hemisphere right bank, in southern hemisphere in the left bank. Is subtropical high pressure horse latitude same? Yes, it is the same thing. Tomorrow I will give you. Current flow area, why fish cultivation so much? My friend, in the ocean current I will discuss that, don't worry. And ये electromagnetic radiation, geothermal energy वाला बात है ना, this I will discuss as I said later on. We will have a discussion on this, don't worry. Current flow area ये हो गया 1318 ना. I remember that. I have stored this for you. Side दें, okay. Please explain how we relate this atmospheric pressure to the patient suffering from the biological pressure in the body. Okay. Are you a doctor? Okay, fine. So I know some of you might have experienced some interesting thing. और एक चीज देखो, मैं कल इसका इम्पैक्ट बताऊंगा. While you have a low pressure outside and our body didn't able to cope up with this, no doubt human being can cope up to some extent, but आपने एक चीज देखा है, while you go to the Mount Everest or climb a hilltop, dizziness होता है if height is more because of lack of oxygen. Also nose से bleeding होता है, जल्दी bleeding होता है. Why it is? Our body pressure is more than the atmospheric pressure there. वो low pressure है, तभी जाके ये हमें bleeding होते हैं. Another thing, in the summer season, if you have low pressure, intense low pressure condition, then also body bleeding होता है, nose से bleeding होते हैं. That is the cause. Okay, as you explained me, as you asked me, so I just explain it in a aspect like when there is high pressure in our body, low pressure. So जिसको high blood pressure होता है, आपको देखा होगा, you have like problem, symptom of lot of things. One is of course eye भी red हो जाते हैं. It moves the blood circulation is such that it will have it have impact on our neurological system also. Okay, this is what is I can say. So thank you very much. See you tomorrow then. Tomorrow we will meet and we will discuss rest of the things. Believe me, do study and come, you will enjoy, and once you will get this, we will have different things will correlate and you will able to participate it in a proper way, because climatic regions is completely depends on these wind system and all. Okay, so thank you very much and have a nice time. Bye bye. Thank you. Bye.